Okay, so I'm going to talk about fundamental data types, just all the basic ones that we use every day in code. Uh, I kind of wanted to go through this just because it's really interesting to see like how to properly use these fundamentals, and plus it's kind of just like any sports game. You got to know the fundamentals in order to improve your game, and so I thought this was a pretty interesting read. Starting off. In code, mostly we use integers or numbers. And just a side note on numbers in general is like when you're using them in code, you want to make sure not to use magic numbers. And these are just numbers that appear in your code. That could be like 47,000 or 12 or something like that. A number that you'd use quite a bit for logical reasons, but the reader of the code doesn't necessarily know what it refers to. So you want to be sure to be very specific in what you say, saying like in a for loop, for example, you can loop through 0 to the maximum number of entries that you can have, or something along those lines. And a lot of other errors occur with numbers, just like dividing by 0. That's a very large one that can happen quite a bit. It can happen without you really realizing it, because floats, as we'll talk about in a little bit, can kind of be equated to 0 in circumstances you won't expect. And so that's something to be cautious of as well. And so obviously, just to start off with, is integers. Like we said, we want to be cautious of division. These things can get kind of messy. And so it doesn't work like in math, where if you divide 7 from 10, it's going to be 0.7 or something like that. It's going to be a little bit off, and so I wouldn't recommend doing that very often. Division's very weird in code because we're only using binary, and so as you can't count up, the numbers don't always add up when you're dividing. Another thing to be cautious of is overflow. Ints can only go so high. I think it's something like 2 to the 32 are possible, but you really don't even want to get close to that. You can use something like a big integer in Java, or like a signed or unsigned 64-bit. You really want to use these different types when you're dealing with very large ints, because ints have their limits for sure. Floats and doubles are another kind of beast entirely. They don't act like we think they do, like I kind of mentioned. I have a program here that it's just a simple loop through Java program that tests doubles. This probably won't print out what you think it will, and so when we run it, we'll see that it prints out 1, 2 like we expect, but then all of a sudden it adds all these zeros. Doesn't quite add up to 8 here, and we're off by 0.000 however many to actually getting to 10. And so that's something to be mindful of. Floats and doubles don't always act like we think they will. And so that's why you really need to set a precision for floats and doubles. Just like that showed you, we'll need to say, okay, up to 2 decimal points I care about this number, but after that I don't. And then that way you'll be able to compare floats and doubles if you really need to. I'd say avoid it if you can, but if you can't, definitely use precision. That's pretty much it for floats and doubles. You just gotta be really cautious. As far as strings and chars go, strings are really easy to use in most languages, like in Java or Python. You can parse them. There's a lot of built-in functions that you can use to iterate through them, like find the ASCII or Unicode values. All those are very useful. In C and C++, not so much. They kind of follow their own rules. C++ and C they add 1-byte null terminators at the end, just so that you know when the string actually ends. And when you first initialize strings, you should probably initialize them to a null pointer at first, so you don't get these endless strings. Off by 1 errors, yeah, use constants. Strings can change in programs, so you want to just be careful of that. Same thing with magic numbers. You don't want to use magic strings that mean something to you, but not necessarily anyone else who reads it. Moving on to bools. Booleans can help clean up your code quite a bit by making these logical variables. So you can take something very dense and very complex and compress it into something that anyone can read. And so it helps you read the code, it helps other people read the code, it cleans it up. It doesn't necessarily make it shorter, but it makes the if or while statements very short. And that's good because if you have like a 3-line if statement, almost no one's going to read through that and glean any meaning from it. They would have to really dig into it and find out what you're trying to say, which is hard. And so, I mean, that's the main reason to use bools. Enumerated types are a little bit strange, but they're kind of the last basic data type. They're not really used too much in like too many high-level languages. It's mostly just C++ and Visual Basic that uses these. You can have like equivalents in Java, but I'm not sure that it would be that useful. But essentially what enumerated types do is instead of having like iterate through a number of like different objects, it's like object-oriented programming. You can make a country that is essentially the same as a int. So say like China equals 1, Germany equals 2, Britain equals 3. Then you can iterate through those and say, you know, if this is equal to Britain, then you do whatever you need to do. It's just a way of reading code, kind of like bools, where it's easier to check through and see them all. And then just to wrap up, I mean, you want to name constants in your code. Make sure that you're not using magic variables. Make sure that when you're dividing or multiplying, especially, you're careful with doubles and floats and even ints. Bools can help clean up your code. Strings and chars are very useful. That's essentially some of the basic data types.